pass the course to maybe anyone. So I'm going to record today. Again, we are going to do just the employee dataset, and it's already recently opened here. So I'm going to click on employee dataset. I will close these other windows so that I only remain with the employee dataset. Again, the assignment I gave you was so simple. Let me demonstrate on how to do that assignment. So the assignment was to import this dataset. You'll do it by the way. Just be keen on what I'm doing. So the assignment was assignment, I think assignment 1 or 2. Was it 1 or 2? Let me see. Okay, so this one. So this was the assignment, and it needed you to record, for example, let me show you. I needed to identify categorical and numerical variables, then run frequency and descriptive statistics and explain the way I did explain them here. So you can see this is what I wanted you to do. So I'll give you the same assignment, I think over the weekend. But make sure that basically, for example, smoking is yes or no, ability yes or no, number of meds, this is numerical, fractures is yes or no. So, but I'll give you a code book that explain what this value means. So at this point, let's just finish up what we were doing on. We are done correlation, and we said correlation is a test of association. We are trying to see if there is any relationship between two numerical variables. So if you're trying to understand any two numerical variables, then the best type of analysis to run is correlation. If you're trying to run anything that is between two categorical variables, as whatever we are going to do today, then the correct type of test to run is what? Chi-square. Then if you're trying to do something to do with categorical and numerical, then the most appropriate test is t-test. So today I want us to cover something on chi-square, test of independence. So the reason if both the variables are numerical, then the right type of test to run is what? Chi-square. I need you to understand that because most of the time that is what we'll be doing. So our test today is remember data management is part of everything. So if you see this is still F and M, the first thing is to record it. You can see. So I'm going to transform automatic record. Then my variable of interest is gender. Transfer it to the other side. Make sure that is gender 2, or just give it a different name. I'm going to call it gender 2. Add and click OK. So it will give it 1 and 2 now instead of F and M. So we have it here. You can see I can now clear this variable and move this one to this other side so that at least it be where it was. So I have my gender there. Again, you can just go back to your variable view and now give it the name that it had previously, that is gender. You can just edit the name from here. So gender. So now it's numeric. So our first question, our research question today would be, I'm just going to look at two variables that I have that are both categorical. So I can say, is there an association between somebody's gender and somebody's employment category or job category? So if I want to understand those two variables, both are categorical. Look at that. So does it, if you are a manager, high chances you have to be a male. So that is what I want to understand. Is there an association between somebody's job category and gender? So the research question would be, so this is my research question. Is there uh, maybe a relationship or an association between, I hope you guys can see my screen clearly, and you're not straining to see what I'm typing. Okay, so is there a relationship between somebody's gender and job category? So basically that is my question. So the number one thing is analyze your variables. My variables of interest in this case is gender, and another one is job category. So come to your, look at these variables. Are they numeric or are they categorical? Or one is numeric and the other is categorical. So in this case, both are categorical. So since both are categorical, we're going to run chi-square test of independence. So does one depend on another? Independence basically means one is depending on another. We are testing for dependence between these ones. Mhm. So we'll start by stating the hypothesis. So the null hypothesis, anybody who can give us the null hypothesis? Mhm. What can be the null hypothesis? I want us to do it. Exactly, that is good. Yeah. So I'm going to, just a moment. Hello. Wow. Yeah, the class is on. Yes. Aja join. You can see Aja join. There's a class going on. The same link. The same link. We use it every day. So sorry. So there is no association between gender and, sorry, between gender and, yeah, and job category. So let me reply to Ian. I think Ian is a little bit late and not sure whether there's a class. Let me resend the link and tell him we are using the same link every day. Okay, so that is our null hypothesis. The alternative hypothesis is, somebody else. There is an association, okay, between gender and job cut. So once we've done that, we have stated our null hypothesis and the alternative hypothesis. The next thing is basically, we are going to do what? State the confidence interval. State the confidence, our confidence interval, which is 95. We are adopting 95. So confidence interval is at 95. So 95% confidence level. So basically this one gives us a margin of error. So that is our significance level. That is 0.05. That is what we are going to compare with the probability value or the p-value to make a decision. So the next part is, we're now going to the software to run the test. We're now going to the software to run the test. So this is our next step. So how do I run that test? Come to analyze, then descriptives, then cross tab. So once that cross tab, let me copy that. I want to screenshot the process. So that is it. As simple as that. Put it there. I'll let it to be a little bit small so that the other part can fit. So I'm doing cross tab, analyze, descriptive, cross tabs. So you can see tulianza na explore, tumeendelea hadi chini. So gender, it doesn't matter which one goes to the rows, and doesn't matter which one goes to the what? to the columns. You can interchange them. So this is the next part. Just transfer that one. Sorry, transfer your variables of interest and click on statistics. So from statistics, check chi-square. So that is what I want you to do. It's as simple as that. Then click continue. So I'll adjust it to make it sure it's a little bit smaller and fits where we want it to be. So basically it is that simple. I don't think this one inaweza kashinda mtu. So let me adjust it kidogo too. So analyze. Hello Ian, welcome. Sorry, we've been using the same link every day. So just make sure you save it somewhere if you can't maybe scroll up the charts to find it. So we're doing chi-square and we're saying to run chi-square, you go to analyze, descriptive, then crosstabs. We have done frequency, we have done descriptive, we have done explore. We are now at crosstabs. Then from crosstab, transfer the variables of interest, then click statistics. And now click chi-square. Make sure chi-square is checked and click continue. Click continue and click OK. So you're going to have a contingency table. This one tells us how many females are. You know how to get this one, right? The other time I asked you how many females are custodials. Then I was telling you just do crosstab without doing any other thing. So if I ask you how many females are custodials, you don't need to check this one. You just need to come to this point, transfer your male, your gender, and your job category, employment category. And you get a crosstab without the chi-square, just telling you how many males are female, how many females are male. The same concept with split. Okay? If you do for split, which is basically come to descriptive, then explore. Again, doesn't matter which one goes there. Just look for gender is categorical. Let me see. No, it's not this one, but it's fine. It tells us the same thing like exactly. Employment category for male and female. But it's not making sense at this point. That's why I say it, because it basically tells us which are male and female. So I'm going to do away with this explore. So basically it's crosstab. So crosstab is what you need to do to get whatever you're seeing here. So you need just do crosstab. So for our case, we've done crosstab with a chi-square test. So the table we're interested in is this chi-square. I'm going to copy it and take it to our document. So these are the results. And from this result, you can format it better. You know, formatting is now part of another thing. So you can need to format it better. And what we are looking at is the Pearson chi-square. This is what we are looking at. I need you to be very sure what we are looking at. And the exact value we're looking at is this value, 0.00. So our p-value is 0.00. So who is going to make a decision? Do we reject or fail to reject? The decision is going to be do we reject or fail to reject? Joyce? We reject. Yes, good. That is correct. So we reject the null hypothesis. And our null hypothesis was we have rejected that there is no association. We have rejected this one. So we are going with there is an association. So we can conclude that our conclusion can be, so why are we, if you ask why are we rejecting, is because our p-value 0.00 is less than the alpha value 0.005. 0.05, I mean. So basically, that is the reason. That is our decision rule according to what we did the other day. Then the conclusion, we can say that there is enough at 95% confidence interval. At 95% confidence interval, there is enough evidence to support the hypothesis that there is an association. There is association between gender and job category, employment category. So basically, that is supported by these. Now, these whatever we are having here, these descriptive statistics here. So if you look at this cluster, majority of females tend to be what? Clerks. Majority of males tend to be custodials or managers as compared to males and females, right? So basically, that is what this table confirms to us. These tables you're seeing here. You can see it declines that if you're a male, then there are high chances you're going to be either clerk or a manager. But if you're a male, you'll either be custodial, manager, or few of them are going to be what we call. Few of them are going to be what we call clerks. Basically, that is it. You can see this data tries to tell us what is happening within these categories. So that is how to run chi-square. The next thing is running a t-test. A t-test is now if you have, we say t-test is anything, if you have anything of mean comparison. So mean comparison tells us about, for example, if I want to understand, is there a difference between male and female in terms of their earnings? Are they earning the same or they are different? There's a difference in their earning. So it's basically mean comparison or comparing comparison of means. So how do I do t-test? So for example, my research question, find out whether there is a statistical difference between in salary for male and female. There's a statistical mean difference. So somebody might ask you, on average, do you think a male is earning the same as a female? So average means mean. Maybe just before I go there, somebody might be asking, what are some of the applications of these tests we are running? So these tests are very important. They're very important. They're applicable in real life. For example, this one called chi-square is the one that was used to identify something between somebody's eye color and their hair color. So there is that difference. I'm sure maybe we are not aware of that, but there is a test was run to confirm that there's an association between somebody's their hair color and their eye color. Another one is in production or industrial manufacturing. They try to associate uh, different machines with default products. So those are both categorical. So machines can be categorized, and again, products are categorized. So we can be able to find if there's an association between this machine and the product they're producing. So some of the tests that they were using to do that was this chi-square. So these tests are applicable in real life and they are used. Again, if you look at something on how somebody came to realize that if you give maybe a kid a soda, those guys they need to be so energetic. It's because they realize that there is a certain association between the sugar levels and now the quantity, the energy produced within somebody's body. So there's a suggestion that was they did a study to prove that that is true. If you take energy, not energy drink, but if you give them anything that has sugar, then you tend to be more energetic and more active. Basically, that is it. So these are some of the tests that were run to come up with that kind of conclusions. So today we are going to do whether there is a statistical mean difference between in salary for male and female. So analyze your variable. The first variable is what? Salary. And I'm going to use current salary. The second variable is male and female, which is gender. And gender is categorical. So we are having a categorical and a continuous variable. So the test to run is a t-test. So we are going to run what we call an independent sample t-test. This is the most common of t-test we're going to do, independent sample t-test. So for an independent sample t-test, you have to have a two-factor categorical variable, which is male and female for gender. So I'm going to state our null hypothesis this way. So this one is a kind of different kidogo. So we are trying to look at if there's a mean difference. So I'm going to say mean one. Let me just write it. It's always called mu. So if you see this term mu, it represents mean. This term here. So mu one. If you subtract the mean for male, let me write male, and mean for, if you subtract it from the mean for what? Female, you get 0. So getting 0, it means there's a statistical difference. So M for F for female. So if you find the difference between the mean for male and the mean for female, it is 0. So meaning they are earning the same thing. So i.e. male and female are earning the same thing. Male, mean for male and mean for, so this is basically what I mean. Mean for male and mean for female is the same. The reason why I'm saying is that if you subtract the two, you get a 0 if they are the same. That is our null hypothesis. We are assuming that they are the same. It means if you subtract the two, we get what? We get 0. That's what this statement implies. I don't know whether you guys are getting how to state this one now. Nanipata? Joyce, Nanipata? Again, now this one, it's not equal to 0. So subtracting mu1 and mu2 is not equal to 0. And not equal to is denoted by this one. Okay? So mean 1, mean for male, are not the same. So if they're not the same, then if you subtract, then you're going to get a value which is not equal to 0, right? If it's equal to 0, then they are the same. If not equal to 0, then you're going to get something. I don't know whether you're getting that, right? So let's go. Our confidence interval is basically the same, 95, giving us a margin of error of what? 0.05. So somebody can do it, but at 99, giving us a margin of error of what? Let's say 0.05. Just a moment. So to do t-test, let's go to state spaces, analyze, compare means. Then whatever we're doing is an independent t-test, independent sample t-test. So these are the ones, they are not so common, but I'll show us how to run them as well. So for this one, we are doing it for the test variable is current salary. Then the grouping variable is gender. Just it's by default. You can't take current salary as grouping variable. That is numeric. The one that has groups is here, gender. Then you can see it's not active. You need to define what? Grouping. So we have one and two for male and female, basically. Then click continue. And now it's active. So let me record the process. So analyze, compare mean, and sample t-test. So from here, transfer your variables of interest, and the next thing is defining. So after that, we can now define. We can now define groups. Make sure it's defined one and two. So this is very, very important. Let me check it there to make sure you can see everything. Then click continue. So define groups, very important. So after defining groups, click OK, and you have your continue, then OK. So once you click there, you have this table, a t-test, comparing the means. This is the statistics. For male are earning about 26 on average lead for the females, and the males are earning about 41 with the standard deviation and a standard error. So what we are looking at here is the t-test. There is Lavin test and there is t-test. So the p-value you're looking at is this p-value written here, this one. See, there's a side for Lavin test. So Lavin test is basically used to test for what we call whether the variances are equal or not equal. So for this one, we are trying to test for t-test and equal equality of means. So the one we are looking at is this one. So you might be confused that why am I looking at this one and not this one? So the reason why this is a Lavin test, a different test, but the one we are interested in is this one called the two-tailed significance. So this is our value. What you do is just take it to the software. Let me take a picture, a screenshot, and take it to our. So this is our result. Our result is here. And since the p-value is actually the p-value is the same, less 0.00, you can see it's 0.00. Again, this value is not 0.00. The value has been truncated. So if you click on it, you'll see a very long value. These values are not whatever you're seeing here. They are very long actually. So the ones that are showing you are just basically trimmed to 3 decimal places. Look at that. The values is it's not 0.00. It's very long. It's a long value. So our p-value is 0.00. It means we are going to reject p-value 0.00, which is less than 0.05, our significance level. So we reject. So we reject the null. So anybody who can explain what rejecting the null mean? So this is the null hypothesis. This was the null hypothesis. Anybody who can explain to us what rejecting this null hypothesis means? If you reject this one, okay? Yes. What does it mean? Exactly. There is a difference. You can find some difference between them. That is good. That is very good. That is very good. Somebody would start. There is no relationship. There is a relationship between male salary and that is no. So it means, therefore, we can conclude. We can conclude that there is mhm, independent sample t-test. Yeah. Then there we conclude that there is a mean difference between in salary between male and female. So I'm talking about regression, multiple linear regression, and it has this question. And this question is one of the most important questions in life. Because once the machine has given us these values, then we just replace the variable here and we can predict your salary. That's how your laptop, your phone can tell me when, if you wake up in the morning, the first social media account you go to, because it has learned your behavior over the years. We have given it data. We have given it so much data. When you use it daily, you feed it with the data. And if you wake up in the morning, I'm sure if you give me your phone, I'll tell you what to do the first thing. Okay? Maybe we might not have the same knowledge to do that, but personally, if you give me your phone, I'll be able to tell you what you do in the morning, the last thing you always do before you sleep with your phone. How many minutes do you leave it before you sleep? How many minutes when you wake up? It has that information. If you go to your web browser, you just try typing anything. It will predict you. It will give you a list of suggestions. Those are basically predictions that these models are doing to help you ease your thinking. And I've said the model is at the moment, in terms of artificial intelligence, in terms of algorithms, human beings are being overtaken by these machines because they can now do everything. They can drive, they can communicate. That's why you can see there is these bots. There is bots within, chatting bots, bots that can help you solve anything. There is these things like ChatGPT. There is these things like there is a lot of AI tools. Basically, what they're doing using is this called regression. You feed it with data, it compares across the world which matches whatever you're doing. Then it can now predict or give you a very accurate answer. Mhm. And you have the question. I've said why is the dependent variable, and a dependent variable is the outcome variable where we want to see the change. Where we want to see the change. So we want to see how much we want to predict your salary using your education. Okay. We want to do what? Predict your salary using what? Education. So the education is the dependent variable. So in this case, i.e. education. So these are factors that influence somebody's salary. We can talk about experience. We can talk about education. So X1 might be education. X2 experience. X3 maybe your field. X up to the less value you're having. So independent variables, i.e. education, are the factors that influence the independent variable. So they cause the change in the independent variable. In the dependent. Are we getting what I'm talking about? Am I simplifying it or making it complex? Sylvester? Doris? Yes, Doris? Mhm. So these are factors that influence the dependent variable. Thank you, thank you, thank you. Okay, that is good. That is being keen. Thank you so much. Mhm. Uh, Boaz, Ian, Cyrus, Joyce, you guys trying to understand what is regression and its applications in the real world. Okay. So in most cases, if I'm doing machine learning, if or I'm teaching machine learning, for example, I can give you project to find a malware within a system. So detection, things like detection of malware within a system, we just set an algorithm that tries to read whatever is correct and identifies the mistakes, then gives us an output that we need. So those are some of the things. Cybersecurity, things to do with detection of malware, things to do with detection of invaders within a system. These are some of the algorithms that have been used to do what? To understand, to try enable you get to understand when did this guy come in, how did they manage to. So they just write algorithms to try understand that. Are you getting that? So to run regression analysis is very simple. So whatever we just the example I've given us here is called, this is what you call, let me just take it down there. I'll leave it up there. But this is what you call a simple linear regression. Simple linear regression. So simple linear regression, it just have one dependent and one independent variable, like education and what? Education and your salary. So to run regression, so basically it itakuwa to very simple. It will just have this one. It will just have that one peke yake, haina mambo mingi. So if it has several independent variable x1, x2, x3, x4, then it becomes multiple linear regression. Are we getting that? So to run regression is simple. Just come to analyze. Then we are going to regression. Then linear. Very simple. I don't know why it's not capturing that. But analyze, regression, then linear. Analyze, regression, and linear. Simple. Very direct. So you will have place where we are going to look for dependent and independent variable. So once you identify a dependent and independent, it's simple. So regression, analyze, linear. So I'm going to look for dependent variable, and we said the dependent, what we are trying to see the change in the current salary. And our factor that is causing a change in current salary is what? Education level. So we can have previous experience, we can have months inside, we can have others. So if you click OK, we have these tables here. We have the model summary, we have the ANOVA table, and we have the coefficient table. So let's copy this one and explain how this, let's see how these tables are interpreted. So the first thing we need to interpret is the model summary. And what you're going to interpret at the model summary is very simple. This value here. So the R squared. Look at the R squared. R square. So the R square is 0.436 multiplied by 100 to get it in percentage form. So we have 43%, 43.6%. So how do I explain this one? So I can say that 43.6% changes in your current salary, can be attributed or explained by changes in the level of education. So basically that is as simple as that. 43.6% changes in the current in your current salary can be explained or attributed. So explain or attributed means the same thing to the changes in education. So if your education change, then we expect that your salary to change by 43.6%. So basically The R square tells us the percentage change in your independent variable that is attributed to the dependent variable. I hope that is clear. As simple as that. The next one is this called ANOVA table. So ANOVA is basically analysis of variance, the variation between the different, that is it, the variation. So the next one is number 2, ANOVA table. Analysis of variance, that is what ANOVA means. So for the ANOVA, we are going to look at this significance. So the significance is where we can now tell us whether the model is statistically significant. So we're having 0.00 and it has something called B. So basically it means it repeats itself. It has a lot of some other values. If you click on it, like I said, you'll see the values are so many. You can see if I move around it, I have them. So the ANOVA table, this one tells us the overall statistical significance of a model. Tells us the overall of our model. So if the value is less than since 0.00, since 0.00 is less than 0.05, which is the 95% confidence level, then we can conclude that the model is statistically significant. That is basically what it means. Okay, so there is how to calculate these ones. I don't want to go there. That is mathematical. The last table is here. The last table is what you call the coefficient table. So if you're doing a research, you have to explain those three tables. Coefficient table. So coefficient table is here. It tells us if, number one, tells us whether the variable is significant to the model, tells us whether the variables are significant to the model, i.e., look at the p-value for education. Is it significant? So if it's less than 0.05, then it is significant. I.e., look at the p-value for education if it's less than 0.05, then it is significant to the model. To the model. Otherwise, it is not. Again, we talked about this equation here. We talked about this equation here. So where is our y? So our y is I want to explain beta naught and beta 1. So y is salary. I want to predict somebody's salary, and I have a coefficient. The constant is already even written here. So our constant is negative, that one. Sorry, negative. So I'm just going to paste it there. That is our constant plus beta 1. Beta 1 is now beta for x, the coefficient of x, which our x is level of education. So our x is education times education. So this is education. Okay. Then we're supposed to multiply that beta 1 and the level of education now. So somebody's level of education, you just come at this point and look at their education. So for example, the first person education is about 15. So you multiply by that 15 to get their salary, expected salary. So that is basically what I mean. This is now the regression equation. Somebody tells you to predict somebody who is, let's say, 29, predict somebody who is 29, you predict their salary, then just multiply this one, then add it to this one. They'll find their current salary. Somebody should do this one. So I want to do it on a calculator. So I'm having negative, negative, or let me just multiply first. So let me multiply 3909.907 times 15. So times 15, you get 15. Yes. Yeah. Uh-huh. Okay. Yeah, basically that is how to predict. You just find somebody's salary. Once you know their, for example, their level of education, which was ranked this way, you can now multiply this and add and find their salary. Is that okay? So that is how the machine does the prediction, and it makes it so accurate. So again, the next thing you need to say, explain here is this value. You can see this value. So beta 1, let me explain beta 1. Interpretation for beta 1. So that is it. So beta 1, beta 2, beta 3, beta 4, they tell us that a unit change in, for example, the dependent variable would cause their value change in the independent variable. For instance, what I mean is this one. Let me reduce the font because I want to make this thing to fit in this page. Ndio nisiende page ingine. So let me just reduce the entire font to, let's say, 14. Yeah, to get that space there. So what I mean here is this. You can see this value here. I want to make sure you can see everything. So a unit change in your education will cause your salary to increase by 3,097. So basically that is it. A unit change in the dependent variable causes your salary to increase by this beta 1x. So if it's negative, then it reduces. Okay? So a unit change in your salary will cause, a unit change in education will cause, so it basically the change in the dependent variable that is seen in the change in the independent variable that is seen in the what? In the independent variable. The dependent variable, the change in the independent variable, which is education, that is seen in the independent variable. In this case, we're having salary. The dependent variable, salary. So a unit change in your dependent variable, education, will cause the salary to increase by this value, the value of beta 1. So if it's negative, if you're seeing a negative before it, then it means it decreases. Is that okay? So let's run a multiple linear regression. So multiple linear regression means you have multiple independent variable. In this case, I'm going to have analyze, regression, linear. Then now I want to look at factors that may affect my salary. Things like, let me talk about employment category can affect my salary. Things like previous experience might affect my salary. Okay? Yeah, maybe let me talk about gender. Let me see whether gender is affecting my salary according to this data or even minority classification. Yes. Yeah. So I've included employment category here. So let me click OK and see. So you can now see when these factors are more, now my R squared has increased. So 72% changes in my salary is explained by the changes in minority classification, gender, previous experience, employment category, and level of education. You can now see that it has increased. The variables, we can see that the model is statistically significant. Overall model, this model is statistically significant. Now look at this value. Again, we can now have these ones. Constant is now 12,407. Then we have education 16, 12 for employment, previous experience, negative 12. Gender having a positive. And all these variables are significant to this model. And even the minority classification, because they are less than 0.05. It means they contribute to your changes in the salary. Okay. So basically, that is how to run it and how to explain these variables. Is there any question?